Hello, everybody, and welcome to today's webinar, Modern Data Modeling for Today's Business. Today's webinar is brought to you by Looker. Before we get started, I just want to go through a few housekeeping things. First of all, we will be doing Q&A at the end of the presentation. You should see a Q&A box on the right-hand side of your console. If you do not see it there, there is a menu bar at the bottom that should allow you to pop that little widget open. Feel free to send in your questions throughout the broadcast, and we will again go over those at the end. The other thing is that we are recording this, and we will send you the recording as well as the slides. So no need to take notes or anything like that. We will send you everything tomorrow. Alrighty, so today I am joined by John O'Keefe. He is the VP of EMEA for Looker. Welcome, John.
Thank you very much, Elaine. I'm really looking forward to the session.
Great to have you, John. We are also joined by Gerard White. Gerard is a data analyst at Looker. Welcome, Gerard.
Thank you very much, Elaine. A pleasure to be here.
Wonderful. And without further ado, I am going to hand it over to John, who is going to get us started with this.
Great, thank you, Elena. Hello, everybody. My name is John O'Keefe. I'm VP of EMEA for Looker. So I thought I might just do a very brief introduction to Looker for you. I suppose, first of all, what I really want to say is that Looker is not just another visualization BI tool. Looker is very much a modern data platform in a very new data world. And really our goal is to deliver on the promise, I suppose, of data that drives your business and really help create a culture and a data culture for organizations, in particular our customers and anybody who's evaluating Looker. So I suppose to help understand how we can get there and achieve those particular goals, I think it's well worth our while just looking through the three main waves of BI and data analytics over the last couple of decades. So with that, the first one I really want to speak to is the first wave. And the first wave is really about 20 to 30 years ago. Unfortunately, I'm of a certain age and a certain vintage that I remember this very, very clearly. So I can probably talk to it with some, some knowledge. And it's really an era of the monolithic BI stack. This was very expensive infrastructure. It obviously included lots of big and expensive BI solutions, whether that was Cognos or business objects and so on. But it also consisted of big and expensive ETL solutions, whether it was Informatica, for example, and other solutions like that. And guess what? That then also sat on very big and expensive databases, whether Oracle, Teradata, and so on and so forth. But not only were these this infrastructure expensive, but it was also quite slow in terms of change of processes. If you needed to make a change, for example, then that did take a lot of manpower to actually maintain, for example, and to make those changes. So with that, they involved various different people to do that, whether it was data teams, MIS teams, and so on and so forth. But it also offered some benefits. It offered such things as standardization, for example, of data and databases. It allowed some consistency around that data, governance around that data for that matter as well, but also enabled business users and end users to be able to be confident in what the analytics and reports that they were getting in terms of the consistency of that data and that it was 100% correct. However, there were some major limitations as well. First of all, it was a case of, because it was quite slow and expensive to maintain and run this type of infrastructure, it was very controlled by those data and MIS teams. So therefore, to ask for report analytics took a long time to get that information. And potentially by the time you got that report or analytics, it may well have been out of date. It could have been weeks, it could have been months, for example. And also from a technical perspective, to do that analysis, was quite difficult. It would need maybe cubes to be set up and so on and so forth to be able to run those analytics, because the databases themselves weren't able to run those various large data requests and so on and so forth. But that then changed about 10 or 15 years ago and really introduced the second wave. And the second wave is pretty much, the last 10 or 15 years, pretty much where we are today. It really took that monolithic BI stack and really mashed it into pieces, really. But I suppose it's also worth taking a step back and maybe having a look at what this era looked like, and give it a little bit of context. If you think about it, it was an era of, on demand. A lot of people were able to, for example, get emails on their mobile devices and so on and so forth. Maybe it was Blackberries, but they got email when they needed to. It was the introduction of SaaS solutions such as Salesforce, NetSuite, so on and so forth. So the business users were able to access information far quicker than they ever had done before. And guess what? That meant in terms of BI solutions as well, that they wanted to get their reports and analytics pretty much on demand in a self-service environment, and be able to get that really, really quickly. So with that, there was basically an era of departmental tools, and this is what I mean in terms of how that stack was smashed into different pieces. And what it meant is that you ended up having a myriad of various tools, some of which were visualization tools that were able to present very good graphs and so on and so forth, and charts. But then also to support that, you might have had some data preparation tools, for example. You might have had other different tools such as discovery, ETL tools, so on and so forth. But in the end, you had multiple tools doing multiple things. And that was good to a certain extent. It helped business users to get that information quickly and get that data analytics quickly, and to be able to present it in really sophisticated visualizations, and also for them to be able to do their own self-service around, they asked the questions and they were able to get their answers. However, what that also ended up doing in terms of the data is that it meant that there was lots of data engines, lots of data silos, and ultimately there was no data centralization, because in order to break that stack up, there was silos of data extracts, and ultimately there was no single source of truth. There was no governance for that matter, and no standardization around that. And ultimately what ended up happening is that there was, yes, answers to questions, but there was a question mark in itself in terms of how accurate that data analysis was and is. So I suppose just to maybe summarize those two issues for you, or those two waves, there's probably two main issues. First of all, in the first wave in particular, there was data breadlines. And what I mean by that is that if you're a business user, then you had to go to that data team or to that MIS team and ask them for the report or the analysis that you wanted. They had to go away and try and process that within that BI stack. And that might have taken, as I said, a certain amount of time. Could take weeks, could take a couple months. And guess what? There was a line or a queue of business users looking for information. And how they kind of resolved that to a certain extent was the second wave. And that's when you started having visualization tools, and I suppose that the departmental tools across the actual stack itself. But that ended up causing data chaos, because everybody had a different version of the truth. And therefore, there was a certain amount of what we would call here at Looker data brawls, because everybody was debating whether the actual data and the report analysis was accurate or not. So that brought us to, and brings us to, the third wave. And the third wave is essentially where Looker is. It's a new, modern data platform. An approach which is the future of BI. And again, even before I talk anything about Looker here, I do want to talk a bit more about, I suppose, what was quite the significant moment here, which is the evolution of those databases. And what we've seen, I suppose, as part of this third wave is a introduction of big databases for that matter, in particular MPP databases, for example. Some of you might be very aware of Google BigQuery, Amazon Redshift, Snowflake, and so on, but also some on-premise solutions such as HP Vertica, for example, and so on. There are lots of these very fast databases, very modern databases now that are able to analyze vast amounts of data really, really quickly. And that has been a huge shift and has really been a cornerstone of this third wave. And that in itself has meant that the data infrastructure and the data infrastructure revolution, for that matter, is relatively less expensive to run and maintain than the monolithic stack of the first wave. And compared to the second wave, where there was lots of silos and extracts of data, you're now able to centralize that data very quickly, very easily, and really have a single source of truth and a single source of data again. And that allowed vendors like ourselves, like Looker, to be able to create really innovative platforms on this data infrastructure. So with that, what Looker is really trying to do now at the moment, and what our customers are finding with Looker, is that we're solving those two main issues from the first wave and from the second wave around data breadlines and data chaos. And what that means for data teams in particular, it means that now data analysts and so on can create new ways for business users to explore the data in a governed and standardized environment. It also allows for those data users and data analysts to be able to create very flexible data models that make sense to the business. And that's really what Gerard is going to be speaking to largely today. And also be able to deliver that on a scalable environment that moves as quickly as the business wants it to move. And that's really, really important. And the second part then really for the business and for the end users is that now they have not only the ability to be able to self-serve and be able to get the reports and analytics that they want on demand, but they are able to be confident in the fact that the data that they're actually looking at and analyzing is centralized, is a single source of truth, and guarantees that they're getting accurate results for that matter as well. But not only are they able to ask those what questions and to be able to get that accurate information, but they're also able to ask the why questions and be able to drill down into that underlying data, into that underlying single source of truth, and be able to be confident again for in terms of what data they're receiving and what reports they're getting, and being able to drive the business forward. So what does that really mean for today, in today's environment for that matter? It really means that this third wave not only leads to a technology advancement, but it also leads to very much a cultural change as well in organizations. And now there's a shift to data really being able to deliver on that promise of being able to drive your business forward. And with that, I'm going to hand over to Gerard, who's going to talk specifically around the data modeling piece today.
Thank you very much, John. Thank you for the introduction. So yeah, my name is Gerard White, and I'm based in our London office. I'm a data analyst, and I'm excited to talk to you guys today about the concepts broadly of data modeling, how we can use it, how we got here, and sort of what that means for businesses today. Sort of just to reiterate on what John said, how do we use data modeling to bridge that gap between the highly governed but somewhat cumbersome world of wave one, BI tools, and the somewhat uncontrolled but much more flexible world of the second wave of BI, right? Now we do this by putting a data model at the front and center of our approach to BI. The data model is at the heart of everything we do. It's not an optional extra. It's something that we have to go through to get to any kind of data. Now, when we talk about data modeling, what do we sort of really mean by that? I guess the perspective here is how do we take raw data and turn it into something that's useful and meaningful to our business users? We can even take it further, ideally, because we want something that's actionable. We want our business users to be able to use data to do their jobs. We might want to analyze maybe a user's behavior through your website, or transaction volume or system performance or whatever your data domain demands. And our data model can help us facilitate that. Now, if I was to sum up BI, I guess in one sentence, it might well be this, right? Just make me a report. And it sounds really simple, but it's not. It's really hard. And that's because data is everywhere, increasingly, and not all users are equipped to understand or appreciate the complexity and the nuance behind it, right? And this is demonstrated, I guess, in this diagram, but also in the industry that has sprung up around helping people make sense of data, right? A multi-billion euro industry. Things like, Hadoop, big data, MPP databases, the hundreds of data visualization tools out there, all aimed at helping users, make sense of their data. Now, one thing we see all the time is that users often know that they have the data to hand, right? They know that it's there to answer a question that they want answers to, but they can't quite get there in terms of answering. Maybe that's because people with subject matter expertise aren't available, the data hasn't been modeled appropriately, etc. But a strong data model can really help us out here because it helps us shape the data that we already have towards sort of steering us towards making better decisions. So really, I wanted to just sort of talk a little bit about the traditional approach that we've seen over the past years and decades mainly. Whenever we think of data modeling, we often think of it as this sort of slow, cumbersome, heavily architected process, right? It starts out on the left-hand side here where we've got lots of different data sources. This is where our ETL, the extract, transform, load team jumps in. And they're going to move the data in some kind of way to some kind of place, typically like a heavily manicured data warehouse. And from there, maybe the EDW team jump in and they start to reshape the data, right, based on the questions that they anticipate getting answered in advance. So they might, manipulate it into a star schema or cubes or separate data marts to different people, etc., summaries. And then the BI team get involved, or the reporting team, taking that and maybe offering up a self-service environment or building out dashboards or reports, sort of again based on what they think business users are going to require. And the problem here is really at every stage, we have to define what we care about upfront, often at every stage. And that limits end users, or end business users, right? And this is why we've had the explosion of self-service BI tools, which are much faster and less restrictive for the end user to ask questions. So while all of this process works, it's not particularly iterative, nor is it agile. We're defining our questions up front, and any kind of self-service element is hardwired into the platform. And really, if you think about it, a lot of it was designed with hardware constraints in mind, right? This was designed whenever databases were computationally expensive and slow. So that was the traditional approach. Now, what we want to do is bring modern software design philosophies into the BI world, right? Everywhere else in software development, the concept of object orientation is not new, right? It's been around forever. And the notion here is really reusability as much as possible. Don't repeat yourself. We can start out by building smaller chunks of reusable code, right? Of reusable metrics and ideas, and then layer these up into higher levels of complexity and sophistication. So to give an example of this, let's say we're looking at customer behavior, right? Account behavior. A customer might have a number of behaviors associated with them, maybe like the number of purchases, number of support tickets, the number of returns, average sale price, number of interactions. And all of these can be defined separately. And there might be, a lot of complexity behind each one of those metrics alone, but they can all be defined separately. Now, what we can do to really make this powerful for business users is to combine all of these into one new metric, right? Let's call it customer health. This is something we use a lot internally. And this is really, really useful to our business users, right? We're taking these smaller pieces and combining them with some kind of weighting based on need into scoring our customers in terms of health, right? And we can also maybe use these smaller pieces in other ways, right? Maybe we want to look at different personas of customers, right? Maybe looking at our serial returners, window shoppers, people who like to get support, etc., etc. Now, going back to customer health, this customer health metric can then be charted or visualized in the same way as if it were a raw object in the database, right? So it can be put on a dashboard or even scheduled, right? Let's say, for example, I've got 100 customers who were healthy last week, and then half of them suddenly become slightly unhealthy this week. We could maybe set up an alert so that my team knows immediately that this has happened, and they can actually take action based on that. And because customer health has been built up using these smaller constituent units, we're able to drill down and actually find out, well, why is this happened, right? Why have they become unhealthy all of a sudden? Now, here's an example from a real-life model. This is the only code I'm going to show you guys, so don't worry about that. But if we start at the top here, we're looking at, say, approximate usage in minutes, right? How long has somebody used our website or our product for a particular session? And then we might want to use this in different ways. So looking below that, we've got daily usage minutes, and we're saying that's a sum, because we might want to look at that, over the course of a given day or month, or marketing channel, or cohort, right? So we want to sum these up in different groupings. And then we can build on that again, because we can start to feed this into a new metric. We're calling it license health in this case. But we can say, right, well, whenever usage is 0, then 0. If it's between a particular threshold, then let's start assigning numbers to it. And while it's not on the slide, we can then say, right, well, customer health takes license health and a bunch of other metrics, feeds them in and scores it maybe red, yellow, or green, right? Which is really, really useful for a business user because it's quite nicely abstracted and useful. And if any one of these definitions changes, right, to say like what constitutes a return or a purchase, the fact that it's code-based means we just need to change that underlying unit, and all the subsequent units and metrics that are building upon it will be updated as well. Now, there are some important sort of cultural factors to consider when we want to implement a data modeling strategy. And I guess the three core parts here are that modularity that I've mentioned, right? We want to make sure that we've got isolated definitions of things. This is very analogous to modern software development, right? Object orientation, keep things small and build up. The interconnectedness nature of things, right? These different units should be able to talk to each other and build upon each other. And I think the third one is the most important here, having a lightweight architecture. If we remember back to that traditional approach that we had, which was, if you needed to make a change, you might need to go back to do a heavy ETL process, do a bunch of recubing, maybe rebuild 100 different dashboards based on what business users want. That's going to slow down this whole cycle, and maybe business users become disengaged. We obviously don't want this. Now, as John mentioned, database technology has changed a lot in the last 5 years. We're not limited by space or expensive computations in the same way that we used to be, right? So what we really want to do is to pull transformations as close as possible to query time, instead of having to heavily process data in advance beforehand, because this affords us greater flexibility. If we can just change the transformation that governs the data, that's much more lightweight than having to get 4 different teams involved to reshape data completely. And building on that sort of cultural aspect of a data model, we want to get lots of different teams involved. Now, we have to accept the fact that we possibly won't get it completely 100% right the first time. So we want to ensure that the whole process is set up to facilitate model evaluation, right? To really gather everyone, business users, data users, the CEO, all around a shared view of the data, right? Get it out to people, get it into people's hands. Because we want to keep user feedback current and developer performance really quick. So as an example of this, right? If I can take something like customer health, and we've got our first definition of customer health, and my end users are using it in the field. We can then take their feedback and evolve the definition of this, right? So maybe, for example, one of my business users says, hey, this customer is showing up as really, really healthy, but I just spoke to them this morning. Things aren't so great down there. So maybe the score isn't accurate, right? Maybe one of the numbers is being weighted inappropriately. So maybe we need to, play with a few different metrics and then refine our definition of customer health, right? To make it increasingly accurate over time. And I guess the second slant on this one is that even if your model is completely correct first time, it might not be in a week, right? You might get, a new strategic goal or a new data source or a new sort of business challenge that you need to contend with. And having a lightweight model that's easy to change and evolve is really, really important. We're kind of crowdsourcing the definition of these metrics, right? By getting business users involved, right, who are the subject matter experts on this, getting them involved in defining metrics and ensuring transparency is really, really important here. Now, if we don't do this, we lead to a broken feedback loop, right? People will go off and do it themselves. Business users will take whatever data they can get their hands on in order to do their jobs. But what happens here, as John mentioned, is that the notion of a data brawl, that maybe the marketing team are going to start doing different things to the ops team, defining metrics differently, using older data sets or different data sets. You end up with differing measures of things, which is problem number one. Problem number two, I think even more tragically, is the feedback that we could get by getting everyone around a shared view gets lost. Because people are integrating their domain knowledge into their own spreadsheets. And that's only going to benefit the spreadsheet, right? It doesn't benefit other teams or the organization as a whole. So what tools can we use to address this problem, right? This challenge of data modeling. Looker, our product, at its core, is based on data modeling language, which we call LookML. LookML has been in Looker since version 0.1. It is the absolute essence of our product, and it's a data modeling language which abstracts SQL business logic. So those three letters, right? SQL. SQL is the lingua franca of analytics. It is everywhere. It's been around forever, and it will continue to be around forever. In fact, SQL is actually having a bit of a renaissance at the moment with these new MPP databases, things like Google BigQuery, Amazon Redshift, Snowflake. These are all based on SQL, right? SQL is not going anywhere. And SQL is as old as the C language, right? It's one of only two languages in this industry that have been around for longer than 40 years, I think. And it's still in use because it's the right tool for the job. SQL is the way the world asks questions. However, I love SQL, by the way. I'm a SQL developer, so I love this stuff. However, SQL has terrible reusability characteristics. SQL developers tend to reuse their code by copying and pasting, or taking an existing query and modifying it and changing it to what they need. In 2017, that's not a great way to develop software. It's also very hard for people with actual questions, right, business users, to write, because it's got quite a large learning curve. It's quite technical. And there isn't really a mechanism to build out business measures, right? SQL wasn't really designed for that. It was designed to query data. So how does LookML come in? Well, LookML abstracts a lot of the logic behind SQL, but it lets SQL do all of the heavy lifting. So LookML is a programmed model that can be queried, and it compiles down to SQL. So your LookML query is actually translated all the way down to SQL, and that's what the database sees. The database is none the wiser that LookML is speaking to it, because it's all happening in C. It's actually analogous to C++ and C. It all comes down to C at the end of the day. So LookML will generate SQL queries that are efficient and minimal and correct for the database that you're connected to. Fields can be defined in terms of other fields, even in different views, without any kind of performance overhead. And it really lets data analysts focus on the important questions rather than having to write SQL queries over and over and over. So I wanted to sort of do a little thought experiment in terms of the data modeling notion with a simple but highly relatable data set. We've got a publicly available data set based on New York City taxi data from a few years back. And it's based on one table, right? A lot, sort of going back to this point that users know the data's there, but maybe the learning or the value is slightly just out of reach, right? I want to take a very simple data set and see what value we can derive from that by using some modeling techniques. So if you can imagine this table, every row in this table constitutes one trip. So we know who drove the taxi for that trip. We know when they started the trip, when they ended it, and how much it costs, right? So really simple, basic table. And using this from an analytics perspective, we could derive a lot of value from this, right? We know what are our busiest times of day, what are our busiest hours of the day over time, maybe months of year here. What are our average fares and how do they relate to maybe particular drivers or particular journey lengths, etc. And that's a solid amount of analysis from this. But without a model, that's really about as far as we can get. So I want to show you what this looks like with a model, right? With some modeling techniques and process. So while this table is telling us a lot about taxis, it's not telling us anything about the taxis which were empty, right? It's not telling me about idle time. It's not telling me about which drivers were particularly busy that day. But all of that data is in there, right? We know it's in there. We just need to model it appropriately. So building on that, let's take those 4 fields and think about it. If we know when somebody was dropped off, and then we know when the next person was picked up, we can derive idle time, right? We know how far the taxi traveled and how long it travels for before they picked up somebody else. So all of a sudden, we've got these 3 new concepts in which our business users can ask questions, right? We've added vocabulary to our business users and given them more power. Now, we can go further with this and introduce the concept of a shift, right? What about utilization? Which of our taxi drivers are busy? But we know when a taxi driver, did their first journey of the day, and we know when the taxi driver did their last journey of the day, because we can infer a large gap as being the end of a shift, right? So we can introduce the concept of a shift. So we've now got a start time and an end time. So for every shift and every driver, we can see how many trips they took within that shift, right? And we can introduce new concepts, such as the notion of utilization. And we can look at utilization, say, over time or by latitude and longitude, or however we want, right? Now, with this in mind, we can actually go one further, because we can start to look at individual characteristics related to drivers themselves. So for every driver, over time, how many trips have they made? How many shifts have they made? How long are their shifts? And how many trips are they doing per shift? And because all of this is being generated off that one table, we can start to cut this by any kind of metric that's in that original table, right? So by geography, different demographic information about drivers or motor vehicles, etc. And really, we're adding vocabulary to our business users' arsenal so that they can get more insight. So let's compare those 2 worlds. A world without a model gives us pretty simple stuff, trips per day, pretty much. A world with a model gives us a much richer set of definitions and objects to work with. Now, what I'd like to do just real quick is to just sort of show you some quick visualizations on this based on this data set that's actually loaded into Looker. Let me just share my screen right here. So just to show that raw data, this is some SQL which is just going to show us that basic table, right? Taxi.alltrips, and we can just run that query. And it's a relatively dry data set, even by my standards, but we've got the pickup date time, we've got the driver ID and the drop-off stuff, and we've got a bunch of other data points here which we're not going to use, but we can certainly add richness to our data using these as well. But this is the data set in the raw, and if we were to present this to, say, an end user in an exploratory environment, we can see all of our metrics along the left-hand side here. Maybe my end user wants to look at this by, say, date or month or hour of day or season, and maybe just a count. And, we can visualize that, get our raw data, maybe download it into, say, Excel or set up a schedule. No problem at all. But that's really where we start without a model. Now, introducing these more advanced modeling concepts, we can start to do more interesting things because we can present these extra dimensions and objects to our end user as if they were a first-class citizen in the data world, right? So now we've got percent idle, shift length, trip facts, a bunch of different stuff that we might want to use to build our queries. And using that, we can start to build up more and more interesting visualizations and insights, right? So this is our first chart, right? Like when are trips happening during the day? But now we've got things like idle distance by day of week, idle time. When are our taxis not being used? If the New York Taxi Company wants to put out more taxis, they can use this data to actually look at demand and change supply to address that. My favorite one actually here is utilization per minute, right? Because we can see the number of active shifts decreasing. For those of you who are familiar with New York, the actual taxi shift end is 4:30. So it's actually really, really hard to get a taxi there because all the taxis leave Manhattan and they go out to Queens. And the new fleet come back out, right? So there's a massive dip here in terms of your ability to get a taxi. So all of this is actually being generated, off that one basic table. And so this is sort of an example of the kind of things that you can do in a world where data modeling is as important as the raw data itself. That pretty much wraps up everything I wanted to go through. So I guess we're probably going to jump to some Q&A.
Awesome. Thank you, Gerard. That was fantastic. As he said, we are going to jump to some Q&A. We've had a few questions come in over the presentation, but if you have anything, feel free to put that into that Q&A box on the right-hand side of your console, and we'll make sure that questions get answered. All right, so the first question I'm actually going to send to you, Gerard. So the model is easy to change, but it's code-based. So how does that affect the business user's ability to get changes made to it? Do you still have the red line situation because you have to wait for IT to make those changes to the model?
So I guess there are 2 points on this one. The model is code-based. That is very much by design. To really get control and granularity of your data, it needs to be code-based. The benefit of this is that we can start to use modern version control systems, things like Git, to manage our code base, which enables us to commit and roll back and collaborate in ways that you cannot do with sort of drag and drop modeling tools. What we want to do is make sure that business users are using the same metrics consistently across the organization. So the data model, which is code-based, is defined by the BI team, right? By those people who are familiar with SQL. There are a bunch of tools on the front end that do allow users to do things like table calculations, right? So take existing data points presented to them through the model and work in them on the front end. But ideally, if there is a metric that's going to be used by one person or several people, it should be defined in that model.
Great. Yeah, I would also just add to that question that as a non-technical user myself, I find it very easy to get people to update things for me, and then it's there once and everybody has it and everybody's working off the same thing. So you do have that spread of universal ideas, which is really wonderful. All right, sorry to move off topic there. All right, this one is also for you, Gerard. How is the LookML code shared between projects, developers, and business users?
Good question. Git, basically. So Git is the industry standard for version control. It's used everywhere. And so it's committed to a main, for those of you familiar with Git, it's like a distributed version control system where there's one kind of production environment, which is your entire code base, and then individual developers, be that one developer or 100 developers, can actually branch off that main trunk and make changes by themselves without affecting anybody else's environment, right? So there's no need for separate development servers or UAT servers, etc. necessarily. These can then be pushed up to a version control sort of hub, right? A really popular one here is GitHub, whereby LookML can be audited and commented and shared and annotated between development teams. You don't have to use something like GitHub. You can actually use your own internal Git repo if you guys have one already. And so that's how we do that. In terms of sharing it with business users, it's always an option to share the definitions with business users. Now, we'll be defining that in terms of code, so it might not be appropriate for all business users, but if a business user wants to see, right, well, hey, how are we generating gross profit? They could have the option to actually examine that definition for transparency, right? There never needs to be a black box between any of these metrics. And actually, because LookML is compiling all the way down to SQL, from a development perspective, it's actually really easy to audit as well, right? You can see exactly what's being executed at any given moment.
Fantastic. Okay, so also for you, Gerard, how do we deal with aggregate data to improve performance and keep the reusability at the same time?
There are entire books written on this subject. So I guess it often depends on data size. Ideally, with something like Looker, we want to work with the raw data as much as possible because that allows us to, drill down as much as possible to do different cuts, etc. There are times where we need to pre-aggregate data. This is really common certainly for event data. If you can imagine, large gaming companies, with very popular games, they're producing more event data in a day than many companies produce in their entire lifetime. So there is a need to aggregate data sometimes. And while Looker can do this, we've got this notion of derived tables, which can be written back to your database. So Looker can do a lot of aggregation for you. With very, very large data sets, it might well be necessary to push that further down the stack and expose aggregate tables as views within Looker. So it's possible, but it always depends on the data side and use case.
Cool. All right. Can the visualizations be version controlled in Git?
Oh, I guess I'll take that one as well. Yes, indeed.
Yes.
Version control, so visualizations can be defined using code as well. This is really important, especially for people who want to deliver visualizations to their customers, right, in an embedded context. If Looker is providing that visualization layer, it's important that you've got real control, not just over what it looks like, but the auditing and the version control, right? So yes, visualizations and dashboards can be checked into.
Wonderful. All right, so Gerard, for the average organization with disparate sources of data, what is the process and level of expertise needed in order to link the various data sources together in Looker? Is it possible for users made up of teams of non-data specialists, to get their sales, traffic, vendor info linked in order to gain the power of Looker?
So I think the word I would stress here is collaboration. And I say this sort of quite passionately, having been on both sides of the sort of data user / business user divide. If it can be done in SQL, it can be done in Looker, is the general rule. So while you may have maybe a list of customers in Salesforce and a list of customers in another system, if those two objects can be linked using SQL, then instead of having to do this every time you want a report generated using these two different data sets, with Looker, we would instill that data analyst's knowledge, right? We would say, right, well, these two things join on this particular column, and that's it. Now we've told Looker how these tables join, right? What the criteria is, and I understand it's often much more complicated than one column. But if it can be defined in SQL, then it only needs to be defined once, and that way to our business users, they don't see any of that, right? They don't see any code or SQL. They just see that field picker on the left-hand side, and so what we often see is different entities, let's say customer, again, coming from, say, Salesforce and Zendesk, actually being rolled into one entity and presented to the user as if it were one entity. A polished user experience is also as important. And so we can present this sort of information as if it were one object. We also help out as an organization with sort of data analysis and SQL sort of challenges such as this one. So I'd love to have a look at it.
Great. All right. So again, Gerard, for you, does Looker execute queries on the fly, or do you pull data into memory?
So we do not pull data into memory. There are a lot of good reasons for this. Moving data into memory is something that was done, I guess, over the last 20 years. There are a few major vendors who do this, and they did this because memory, right? Random access memory is super fast. You don't get faster than RAM. And so you're going to have like absolutely lightning fast visualization, exploration. The problem is it doesn't scale. I can think of vendors who an hour's worth of their data, or customers who an hour's worth of their data would not fit in RAM. It doesn't scale. So, and another problem here is that as soon as you copy something into memory, you're making a copy of it. And as soon as you make a copy of something, one of those things is out of date. So the fundamental data might have changed, and you're using your in-memory model, which you also have to maintain and deploy. So Looker does not move data into memory. It does not store data. We believe in utilizing the power of modern databases. These databases are getting faster and faster and more scalable every day. And as they improve, so does your Looker deployment.
Great. Cool. So we are actually a few minutes over, but thank you everybody so much for tuning in today, and thank you John and Gerard. It was really wonderful to have you on today. If you are interested in learning more about Looker, we have some information here on the screen. You'll also see a resources list on the right-hand side of your console. Feel free to download any of that information to get a little bit more information on Looker. You can also see the links here. If you'd like a more personalized demo of Looker, please visit looker.com/demo. You may be lucky enough to get Gerard on that demo for you to give you a really in-person look at the product. Thank you again for attending, and we hope you enjoy the rest of your day.